Well, good afternoon, everyone. Today, some of you missed class because of the International Space Station presentation, and it was cool because some of our students got up and asked questions, so that was pretty neat. So, today we're going to talk about 11-4, Chapter 11, Section 4, Roots of Complex Numbers. We'll talk about a couple things in general and then present one example. So hopefully this won't take up too much of your time. So remember way back when we did the fundamental theorem of algebra. And as you recall, the fundamental theorem of algebra said that if you have some kind of a function, maybe a cubic function, that cubic function, because it's in the form of ax to the fourth plus bx to the third plus dot dot dot, it can have at most four, because it's to a fourth degree polynomial, it can have at most four real number roots. And it might have three and et cetera, et cetera. It might have two. It might have none because it's an even function. It could conceivably have no real number roots. It could be one of these guys and have imaginary roots. So today we're talking about roots of complex numbers. So now if we take that same fourth degree polynomial, we're going to say that it has, I'm going to erase this for a minute, get rid of this. We're going to say that same fourth degree polynomial will have four quartic roots, just that some of them may be real and some of them may be non-real, and that's okay. By the same token, a third degree polynomial, something x to the third plus 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 ax to the third, would have three cube roots, etc. Two square roots if it was a second degree, etc., etc. So you saw in your text that the nth root of z, of course, is equal to z to the 1 over n power, and that is equal to r to the 1 over n power cis theta over n plus k times 360 degrees over n. And this k is the one that always throws everyone. And we're going to do an example now to hopefully illustrate how that k works. Okay, so let's say that you wanted to do the, I don't know, the cube root of -1. Let's say that. And that looks really simple to start with. We would write that as z equals -1 plus 0i. Okay? Z equals -1 plus 0i. So that we can then say, okay, that equals 1 cis 180 degrees. Since, and I'll just do a real quick little drawing off to the side, since you're not going anywhere on the imaginary axis, you're only going one unit over here to the left on the real number axis. That's why we get 1 cis 180 degrees. And that's cool. That works. And notice here, I don't need to say -1 because I said 180 degrees, and that gets me over here between the second and third quadrants. All right, let's continue. Using this relationship up here, I'm going to plug in everything I can for this. So I'm going to say z to the 1 over n. Well, we know what n is, so we can say z to the 1/3. And again, that's how I'm getting the cubic root of -1/3, of -1 rather. I'm going to get all three roots because a cubic root will have 3. So 3 cubic roots. So here we go. Z to the 1/3 equals 1 cis. Well, I'm backing up. Okay, I should say r to the 1/3 cis 180 over 3 plus. So my first k is going to be 0, and I'm going to do k equals 0, k equals 1, k equals 2, but not k equals 3 because it goes up to k equals n minus 1. So I'm going to do k equals 0, 1, and 2. So my first one is k equals 0, 0 times 360 over 3. So that gives me equals, in this case, r is 1. So 1 to the 1/3 cis 60 plus, well, 0 times 360 is 0, divided by 3 is 0, plus 0. And that equals 1 cis 60. And that's the polar form. While we're here, we might as well do the rectangular form. So 60 degrees, you can, if you want to, you can make a little sketch. 60 degrees, cosine of 60 is 1/2, and the sine of I sine 60 is then square root of 3 over 2i. And remember, this is the complex plane. So then we have here 1/2 a plus bi, 1/2 plus the square root of 3 over 2i. So there's one root in polar form and in rectangular form. Not so bad. And I think they'll go a little more quickly after this. We can take this same thing and we can say another root of z to the 1/3 equals, again, 1 to the 1/3 cis 60 plus 1 times 360 over 3. And that equals 1 cis 60 plus, well, 1 times 360 is 360, divided by 3 is 120 degrees, and that equals 1 cis 180 in polar form. So 1 cis 180, that one we don't have to think too much about. We know is just -1 plus 0i, which is equal to -1. So there's another root in polar and rectangular form. So let's do another one. C to the 1/3 equals 1 to the 1/3 cis 60 plus 2 times 360. Now this is my last k. So notice here we said k equals 0, k equals 1, and k equals 2. And we're stopping here because this is the third power. Remember, the third power, n equals 3 minus 1. So n equals 3 minus 1 is 2, 1, and 0. So that's where we stop. Okay, so then we have, once again, 1 cis 60 plus, let me see what's that, 20, 240. And so we have equals 1 cis 300 degrees. So let's think about that one. 300. Let's make a little sketch. When in doubt, make a little sketch. That one's going to go over here. No, down lower. That's more like 330. It's more like 330. That one's going to go more like this. And then a cosine again is 1/2. And sine is going to be negative root 3 over 2i. Move that dot and gather them. Okay, here we go. So that gives us a rectangular a plus bi over 1/2 plus, now let's just go minus. You don't need to go plus and negative. Minus square root of 3 over 2i. So there are 3 roots of negative 1, 1 cis 60 degrees, 1 cis 180 degrees, and 1 cis 300 degrees. Very, very cool. Okay, we're 11 minutes in, so I've got a little bit of time. Wanted to take just a moment and talk calculators for you. So let's bring up our calculator here. Hopefully it'll come up fast. And all right, so here's our calculator. Now we want to go into mode, and if you want to do this, check what we just did, that example, the cube root of negative 1 on the calculator. We can get part of it, not all of it. It'll lie to us a little bit. Okay, so there's a plus bi. A plus bi, complex numbers. And then I always go up 1 or 2 just to make sure it's still lighted. Then we can go second, quit. And then we can get out of here if we can. There it is. Okay, so now if you try to go negative 1 to the 1/3 power, the calculator will just spit out negative 1. So we have to trick it a little bit and say, well, what does negative 1 equal in terms of imaginary numbers? And you're right, negative 1 is I squared. So where is I hiding on this calculator? Well, it's right down here on the decimal button. But first we have to hit second decimal I squared. And then we can do that instead. And you can do cube root, but I think it's faster and easier just to say x to the 1/3. And let's see what happens. And we get 0.5 plus 0.866, blah, blah, blah. And notice way over here on the side, there's an I. And for those of you who are decimal freaks, that might make you uncomfortable, but the rest of us know that 0.5 is 1/2 plus, and the 0.866 is the square root of 3 over 2i. So it works, and that in fact was one of our roots. And really, negative 1 was also one of our roots. So we can get 2 roots here. You got to be a little craftier to envision that third one where this was 1/2 minus square root of 3 over 2i. But right there you can check 2 of your roots with the calculator. Okay, so we're at 14.5 minutes in. I think I'm going to say for good night for now. Hopefully when you come on Tuesday, you'll have some great questions about section 11-4. Thank you. Bye.